Basic computer hardware. This presentation is going to look at the basics of a computer. If you're already comfortable with the basics of a computer, this is either a good review or move on to one of the other tutorials that's more specific to your needs. But if computers and you don't really understand how the computer works underneath the hood, this is the presentation that'll help explain that, hopefully. First, we're going to look at some terminology. We're going to look at some motherboards, what a motherboard is, explain about it. We're going to look at CPU, the RAM, the sockets, the video card, the power supply, the hard disk, optical drive, network card, hardware versus software, and some basic security. One of the things I want to point out here is that a lot of people are confused when they say between the RAM and the hard drive. RAM is the temporary random, it's called random access memory, but it's temporary storage. Whenever you power off the computer, it's all gone. The more RAM you put into a computer, that'll really impact the speed, whereas the hard drive is the amount of space that it's storing files on the local computer. This is an area where a lot of people I found get confused on a regular basis with it. We're going to look at what I call the magic keystrokes, or a lot of the shortcut keys that are really helpful. This right here is a video that's going to explain how the inside of the computer works.
If you're the kind of person who's always wondered what's inside a computer, then this is the video for you. What we're going to do here is open up a machine and look at the 7 major components that you find inside. The motherboard is the heart of the computer. Every part either sits on the motherboard or connects to it in some way. In this machine, this big red rectangle is the motherboard. The CPU is the central processing unit. It's the brain of the computer. It runs the software and processes the data that you're working on. In this machine, like most, the CPU sits under a big heat sink and fan, as you see here. The people who design CPU chips often leave behind pictures or sayings on the surface of the chip. They're incredibly tiny. You have to use a microscope to see them. But like the Easter eggs in a video game, they're there to amuse and surprise other people. The RAM is the random access memory, and it sits right on the motherboard. It holds the data and the software that you're currently running. On most motherboards, you'll find 1, 2, or 4 banks of RAM. Adding RAM to your machine is a really simple way to speed it up. This is what a stick of memory looks like. To add it to your machine, just find an open slot on your motherboard and slide it right in. This is the video card, and it connects to the motherboard with a special video card slot. The video card creates the images that appear on your monitor. Most motherboards accept either an AGP or a PCI Express video card. Serious gamers will upgrade their video cards every 3 to 6 months to get the best performance. The latest thing is to have 2 or even 4 video cards in a single machine. The power supply usually sits at the top of the case, and surprisingly, it supplies the power that the computer needs. All these different wires that you see in the case are coming from the power supply. A high-end machine can burn up to 800 watts. If you left that machine on 24 hours a day for a year, it might cost $700 just to run it. That's as much as some people spend on a whole machine. This is the hard disk. It holds your information even when the power's off. When you turn the power on, your software and data loads from the hard disk into the RAM. If you've got an old machine that you're ready to donate or recycle, it contains a lot of personal information. Deleting the files is not enough because someone with the right software can undelete those files. If you want to truly erase your data, you've got to destroy the drive. This is the optical drive. It sits in the front bay of your computer, and it uses a laser to read or write CDs and DVDs. CDs and DVDs can take an incredible amount of abuse. The one thing they can't handle is deep scratches. To protect your data, always keep them in a sleeve or a case. So there you have it. Those are the 7 major components that you'll find in any normal PC.
Let's look at some terminology. First, you have TLA, which is known as the 3-letter acronym. Then you have the ETLA, the extended 3-letter acronym, and then you have the EE. which is expanded, extended, three-letter acronym. You're going to notice that there's going to be a lot of acronyms. I will explain the acronyms as we go through, but for some reason the IT technology industry is just really excited about acronyms and they use them all over the place. Online is basically the ability to access your network. Offline is you can't get on the network. So when somebody says, hey, I'm online, everything's working fine, or if they say, I'm offline, I can't get on, well, are you offline and as far as email, or are you offline as far as you don't even have access to your network files and your network drives? Any computer that's hooked up to the network or a device is called a node. This can be a camera, this can be a time card system. I mean, you name it. Anything that can hook into a network is called a node. Let's look at some of the terminology. RAM, which is known as the random access memory. This is temporary storage on your computer. When you're working on it, it helps your computer to work faster. When you power off, it's all disappeared. If you don't save your Word document, it's in RAM and it's gone. Storage is your USB or your hard drives. Now, there are several different types of hard drives. We'll get into a little bit of that today. We won't get into a lot, but we'll look at some of the differences. SATA is one of the types of hard drives. It's Serial Advanced Technology Attachment. SCSI is the small computer system interface. It's typically used on servers, and even a lot of servers are now using SATA drives instead of the SCSI or the IDE or EIDE. And IDE is the old style of hard drives. PCI is basically a device that can plug into your computer. It's a slot on your computer. Then you have USB, which is Universal Serial Bus, which is basically anything that can plug into a USB port. For example, a mouse, a camera. All of these are USB devices. You can have a USB jump drive or thumb drive as they're referred to. NIC stands for Network Interface Card. AGP is Advanced Graphics Port, and it's one of the ways that video, depending upon your computer, may have an AGP slot. BIOS is your basic input-output system. And your CMOS battery, which if you're wondering what that is, it's complementary metal oxide semiconductor. It basically keeps the time and the other settings when the computer is powered off. Does it boot to the hard drive first? Does it boot to the CD-ROM first? All these are set in your BIOS settings. Now we're going to look at the actual parts inside a computer. Right here you have your PSU, also known as your power supply unit. This right here is your CPU, and there's a fan on top of it, sometimes referred to as the cooler. And then you're going to see you got your RAM slots here. You're going to see that you have actually we have a SCSI CD-ROM player here and an IDE CD burner down here. And then we have a floppy drive that's way down here. And floppy drives, in my opinion, I refer to them as grannyware or otherwise known as obsolete. They're not being used. You have a case speaker that's usually built into the computer. You have the physical hard drive. You have IDE interface. That's where a hard drive plugs in, oftentimes the old style hard drive. You have a floppy interface if you're still running a floppy drive. Most modern motherboards don't come with a floppy interface anymore. You have the CMOS battery, which has been the same for forever. Then you have what is known as the North Bridge. We'll talk about that more in a little bit. You have your graphics card inside of here. You have a SCSI controller, which is going to go up to the SCSI CD-ROM. And then you have your LAN or graphics card. LAN stands for your local area network, which is also a LAN card is another way of saying usually a NIC card or network interface card or a graphics card. And these slots are in here. Let's look at the motherboard. It's where everything gets plugged in. If you saw the picture before, everything was plugged into the motherboard. It serves to handle everything and it interfaces with each other. Basically, it mounts the CPU, the RAM, the cards, including your video card. Basically, everything that plugs in to the motherboard some way, somehow. Integrated peripherals. Oftentimes, a motherboard will have a network card built onto it, or a video card and sound card and PS2 ports. Now, if all these are built into your computer, that means that they're built on the motherboard, but they are not upgradable, or you have to plug in another slot and disable the onboard. I highly recommend that you disable, if you have onboard video, you disable the onboard video and you use a higher end graphics card. That's where you'll notice a lot of difference. You're going to see we've got the North Bridge processor socket, you have memory, you have your IDE, you have your South Bridge down here, your BIOS and your SATA and your PCI slots. And right here's an AGP slot. So this is what a typical motherboard looks like, and these are the main items that you're going to find on a motherboard. Let's look at the CPU. It's also known as the central processing unit. Its data is processed here. This is everything to all. It's basically a bunch of math, zeros and ones, dual core, quad core, and so much more. So they've gone from being a single processor to now they've got multiple processors inside a single CPU. AMD and Intel are the main chip manufacturers. What really matters? Basically, what makes a difference is the speed, usually in gigahertz, and the number of cores. If it's a quad core, then obviously you got 4 processors inside of one. And the other big issue with CPUs is the more cores you get into them, the higher voltage they're taking, they get hotter. And the hotter they get, the slower they run. So you want to try and keep them cool. RAM is the kind of like a lot of people's idea of, chocolate chip cookies. You could never get enough. It's known as your random access memory. It basically temporary stores data that is to be processed. The standard now is at least 1 gigabyte. Windows XP supports 2. Actually, it supports almost 4, 3.5. Vista supports 4, or whatever you want to throw at it, as long as you're running Vista 64-bit edition. And Linux and Mac support even more than that. So both of them, because they're based on a Linux kernel, you can just throw a lot of RAM at them. And the more RAM you throw at them, the more they're going to use it. Now, if you try to put more than 4 gigs on Windows XP or, it's not a 64-bit edition, you're going to notice that you're going to have problems, or it won't even recognize that RAM. And now sometimes it may run slower because it's realizing that it doesn't know what to do with a whole bunch of space out there. So you want to make sure you've got the right operating system in order to use more RAM too. Different types of RAM. There's SD RAM. There's RD RAM, which is basically it's fast, but it's old technology. It's not being used anymore. DDR is pretty much what you're going to see out there. DDR2, and DDR2 is the second generation, and DDR3 is doubling the minimum read and write to 8 consecutive words, and DDR4, which is slated for about 2012, is even faster, and it's going to be at a lower voltage. I think they may actually come out a little bit sooner than that, but that just kind of gives you a little bit of an idea of the different types of RAM that's out there. Most computers that are coming out today, you're going to see them as DDR3 or DDR2 is what they're going to be running. I like to call the control freaks. These are the ROM chips. Basically, they store the BIOS and other programs that say when the computer loads, this is how it'll recognize hard drives, this is how it'll recognize CD-ROMs. CMOS storage, which contains user-defined data as part of the setup. For example, do I boot to the hard drive first, or do I boot to the secondary hard drive first? Do I boot to a CD-ROM or a USB drive? That's kind of what the CMOS, where I can go in and set my settings inside there. The chipset is normally consistent of both a north and a south bridge. These are called the controllers, which incorporate very essential functions. And we'll look at these a little bit. Okay, the north bridge, as you're going to see, it's dealing with the CPU, the RAM, the video card, the network card, or Ethernet. So these are high volume, high speed. The south bridge is a little bit slower. PCI Express, USB, ATA, the floppy drive, BIOS, and other interfaces. And this is how they've typically been handled. And there is some change, and there's going to be some change coming along. Basically, the north bridge is often referred to as the front side bus. It does have PCI Express 16, has moved over to the north bridge. Whereas the south bridge is FireWire, SCSI, and all these other things are running from the south bridge. Basically, the chipset's the glue that connects everything together. Let's look at the sockets. Basically, they're holders which have been soldered onto the motherboard. The sockets are built in exactly to match the particular card or chip that are being used. For example, there are sockets or slots where you can mount the CPU and the RAM get put into these slots. There's expansion cards, which are also called adapters, PCI, PCI Express, AGP. That's just some of them. What's it in port? Ports are basically for the keyboard and the mouse. There are serial ports, parallel ports, USB ports, PS2 ports. They're basically sockets where you can plug in, like for your microphones and for your keyboards and all of that. Now let's look at the video card. The more RAM you can throw at the video card, typically the better, because it does a lot of processing, especially if you like to play games. A pixel shader is modern games need this. Pixel shaders are kind of short computer programs with the computer and the brightness and the color of pixels making up the 3D scene. Pixel pipelines. Basically, when we're dealing with video cards, one of the things I want to make sure you, as you get into higher game, if you're really into gaming, you're going to want to get very specific on your graphics card. If you're just doing normal, computer, Word, PowerPoint, internet, that kind of stuff, this is not as critical. But as soon as you start getting into dynamic video or anything like that, all this becomes important. SLI Crossfire, they're basically two SLI graphic cards are on the same system. They work together by splitting the screen in half. And it really, if you're doing high-end gaming, it makes a big difference. The real important point with a video card, if you're into high-end stuff, is your GPU, or your graphics processing unit. It's also called the Visual Processing Unit, or VPU. It's the dedicated to graphics rendering. It helps generate the picture. And the more complex the picture, the more important that is. Power supply is often overlooked. You don't need 1,000-watt power supply. I've seen a lot of people who've gotten into games and they're like, ooh, I need a 1,000-watt power supply. You really don't need to spend that kind of money. Basically, there's different. You can calculate how much watts everything on the computer is going to take. The larger your power supply, the more it's going to take on your electrical bill. If you're running an 800-watt power supply for a year, you're going to spend over $700 these days. You're going to spend about $800 to $900 on your electrical bill a year if it's most of the time. That's one of the things to consider. The larger the power watt, or the more watts you have in your power supply, the more electricity it's going to take. You only need about 350 to 500 for a normal PC. I recommend 500, but 350 is a good amount. Just depends what all's running. How many devices do you have hooked to it? Never open a power supply. Just replace them. If you ever get into computer repair, don't try and open them up, and because there's enough electricity in there to hurt you. The hard drive. Basically, you can have just one hard drive, or you can have what's called RAID, which is redundant array of inexpensive disk. These are on high-end laptops. I've seen, for example, on Alienware laptops, they'll have two hard drives and they'll RAID them together for faster speed. It's also used on servers and other high-end machines. It's a good balance between price and space. I think it's somewhere around 750 gigs to 1 terabyte right now is the good price break. You start going over that, you start paying high-end. You're paying more for the storage than what I think you need to. SATA, you have 1.5 to 3 gigabits. No jumpers, no master slave. When you're set up with an IDE, you have to set one as master and one as slave. It's a little more complicated. This is the old style connector for the IDE drives. The old IDE or ATA, it's also called Ultra ATA 66, and here's a photo of it you can see below. The old school IDE and ATA drives, the controller, they have a controller on the hard drive, connects the hard disk to the motherboard, and you can see right here you have to set one as either a master or one as a slave, because you can only have two on a particular channel. You have a primary channel with a master and a slave, then you usually have a secondary channel with the master and slave. You're limited to a maximum of 4 hard drives inside the computer. And if one is running, let's say this master here is your CD-ROM and then your slave is your hard drive, it's going to run slower because it's limited due to the fact that you've got a CD-ROM. It's better to put, if you are running the old IDE, put the CD-ROM on one channel, put your hard drives on another channel. A cable between their two controllers. Now, the happy days of SATA. You don't have to do master-slave. See, here's your power for your SATA, here's your signal, and traditional power if you don't have the power adapter inside your computer. Basically, it's 150 megabits per second data transfer. Initially, later, it went up to 300 to 600 megabits a second in the newer versions of SATA. It's hot plug, which means you don't have to shut down the PC to install or remove SATA drives. At least that's what they say. Real world experience, sometimes that doesn't always work. It's more intelligent controllers than SCSI. It's like SCSI, but I think the controllers are even better. No jumpers for master or slave. You don't have to worry about setting their SCSI settings. Like on SCSI hard drives, which are the ones used on high-end servers, you have to define, is this going to be, because SCSI has channels, what channel is this going to be on? Literally, with SATA, you just plug it in and it works. Uses usually an 8mm cable. It's inexpensive to manufacture and easy to install. It's great. External storage, you can have CD-ROM drives. They're nearly obsolete in today's. Almost everything's moving over to DVDs or DVD-Rs. Burners, you can burn CDs or DVDs. Blu-ray, floppies I refer to as grannyware because they're just not being used. And of course, you've got thumb drives or jump drives. You can now get them at 64 gigs or higher, also called jump drives. You can also use iPods or watches or several different types of devices. Now let's look at the network card. NIC stands for Network Interface Cards. They connect any two computers or users together. It can be wired or wireless. They can be built into the computer. They're literally plug and play USB NICs that you can go buy. So if your computer doesn't have a network card, you can plug it into a USB slot and it becomes a network card. Once you connect to someone else's, they can connect to you. Remember that. As soon as you get onto the internet can plug into you. Very important. Hardware versus software. Hardware is something you can touch. Software tells the hardware what to do and how to do it, also known as the boss. Firmware is something that you can touch like BIOS chips, but it's editable through like CMOS or something other way, or a firmware update. The boot process, when you first turn on your computer, you have the power on self-test. It powers on, checks all the hardware to make sure the hardware is working at a basic level. When the post completes successfully, the CMOS will identify the boot driver and start the operating system. The OS stands for operating system like Windows, Linux, Mac OS. So you got the bootloader, which seeks the bootable partition on the hard drive, and the boot sector on the hard drive, loads it into memory and continues the boot process. The partition table on the boot drive identifies how the drive is divided up into segments. Is it just all one hard drive, or is it split into separate logical drives? Basically, these make up the master boot record. And then if you're running on Windows, 2000 XP or higher, or Vista or Windows 7, you have your NT loader, which takes over the operating system boot. With all computers, you've got to secure them. I recommend you always turn on your firewall, or better yet, if you're using Windows, use a different firewall if you're not running at least Vista or Windows 7. If you're running anything below Vista, the firewall is very limited in what it can do. Starting with Vista, it got much better, and I recommend using a different firewall. Turn off wireless ad hoc mode, because that means if you've got a laptop, anybody else can connect to your laptop if you allow ad hoc mode. Disable file sharing if you're not using it. There's just a lot of security holes with Windows file sharing. Change your administrator password. If you've not changed the default administrator password, go in and do that. Kind of the daily commute. Remember, hard drives fail, laptops fail, computers fail. Backup, backup, and backup your stuff. Update your antivirus definitions daily. Run Windows Update, software update on a regular basis. And notice this is the daily commute. This is something you should do every day. Don't sign up for free stuff using your email account. Make sure your firewall's on. Update your applications. Specifically, Acrobat is something that's updated on a regular basis. Flash. Because they're so well used, there's a lot of security vulnerabilities for them. Good spyware prevention software should be running an update. Let's look at some of the magic keystrokes. F1 is a universal help in almost every Windows program. Control A selects all the text. Control X cuts it. Control C copies it. Control V paste. Home goes to the beginning of the current line. Control Home goes to the beginning of the current document. N goes to the end of the line. Control N goes to the end of the current document. Control Y redoes the last action you just performed. Control Z will undo the last action. Control P prints. And Control S saves. These are pretty much universal across Windows, no matter what software you're running. You can be running Adobe software, you can be running Microsoft software inside Windows. They'll all do these same functions. A few more. Alt tab switches between an open application. Alt shift tab switches backwards. Alt print screen will create a screenshot only of the program that you're currently in. If you don't want to get your entire Windows or your entire desktop, Alt print screen. Control Alt delete is also known as the three-finger salute. Basically, it'll reboot the computer or bring up the Windows Task Manager. And from the Windows Task Manager, you can stop a process if your computer hangs or it's not responding. Control Escape brings up the Start menu. Alt Escape, you switch between open applications. F2 renames a selected icon or selected file. F5 refreshes the page. If you're an Internet Explorer or you're using something else and it's not showing up the changes you made, try F5. Alt F4 closes the current open program.